So hey guys, welcome to my channel. Today Geeks problem of the day is duplicate subtree in binary tree. Given a binary tree, find out whether it contains a duplicate subtree of size 2 or more or not. Two same leaf nodes are not considered as a subtree as size of a leaf node is 1. Okay, fine. So let's check the example. It the output is 1 because it contains a duplicate subtrees like 2 4 5, and there is another 2 4 5. Let me tell you something. When in any question of binary tree they tell you to find a pattern or match a pattern, try to represent this binary tree in form of string. Okay, like you can ask me what it means. Like if I represent this in form of string, what it becomes like, uh, I'm starting this from this subtree. Okay, like 2's left child is what, 4, and 2's right child is what, 5. So I can make something like this. Okay, for this node 2, the representation of this subtree is like string 4 2 5. Okay, it means this 4 is left child, this 2 is the node, and this 5 is the right child. Okay, now for this one this is a left subtree, right? This part is a left subtree, right? So now if we consider, so this is the left child for this one. Okay, now if I consider one's right child, again it makes a string 4 2 5. Okay, now for this 3 its right child is 4 to 5, and it has no left child. So we can consider it like this: if any node has a right child and or has some right subtree or left subtree, but has nothing, like has a null left child or right child, if it's happened like in this case 3 has no left child, we can replace this value with some special character, right? Like in this case for 3, maybe take a left child because it's null, we consider as hash. Okay, now think for 3 the left child is hash and the right child is 4 to 5, and if I convert it in a string, it becomes hash 3 4 2 5. Got it? Now this is the right child of 1 and this is the left child of 1. So if I want to represent this tree, it becomes like 4 to 5 4 to 5, and then it's the left part, and then the node and its right side like star 3 4 2 5. Okay, from this you can easily say, okay, here I got 2 times 4 to 5, like two string has same, like two same string, right? 2 4 to 5 and 4 to 5. So from here we can say there is a duplicate subtree. Okay, that's why I'm telling you, if somebody tell you that kind of question, or you find out some kind of this kind of question, you always try to convert this tree as a string. Okay, so it will help you to find the pattern always. I think you got my point. And let me tell you something, like here already mentioned, like we are not considering the leaf node. How we know the leaf node? Because you can see here 4 and 5, here 4 and 5 are leaf node. So the leaf nodes have no child, like it has no left child, is it has no right child. So if we found a node who has no left child or right child, we just return the node as a string. Now for this 4, it has no left child, it has no right child, so we will return this 4 as a string. For this 5, it has no left child, it has no right child, so we return this 5 as a string. And now for this 2, we make the the string representation of this subtree like 4 to 5, same as for this whole tree. Okay, let me show you the Python code first. Now I make a set of a string. The set property is it does not contain duplicate values, right? Okay. Now I run a DFS and I set a flag. Flag it actually indicates I found some duplicate or not. Like here you can see, uh, they tells if I have to return one if I found any duplicacy. If there is no duplicate values, we have to return 0. So that's why I initialize this flag as 0 and then define a DFS function. This flag is from outer scope. Okay. uh, if not node, right, if it has no right child or left child, we return a special character. Okay. If not left node or right node, it means what? It has no left child or right child, that means it's a leaf node, so we have to return it like a string. Okay. Now I take a string called tree and it has some left child as well as its node data, like we have its node data I convert it into string, and as well as a right child, and we make a whole string from them. Okay. Now we'll check if its string is present in this set. If it is present in this set, then we can say okay, I found a duplicate and I make our flag as 1. Else if we don't find anything, we simply put this string in our set and return this string. Okay. Now we run this DFS and return this flag. If our flag is 0, if there is no duplicate, then our flag remains 0. If we found any duplicate values, then our flag becomes 1. Okay. Let's compile this. Okay, it's run successfully. Let's submit that code. Yeah, it's also submitted successfully. Let me show you the Java code. So here is the Java code. Here we have a set, a flag, and then we call our DFS function and then return the flag. Okay. For this DFS function is same as the Python code. Okay, you can check it. Let's compile it. Okay, then submit that code. So yeah, it's also submitted successfully. So thank you all. That's all for today.